Got stuff in the camera like that. Your y-intercept is 1, so plot the 1, the negative 1. Then your slope is 3x, so you go up 3 and over 1. This is marvelous. Booyah!
Alright, today's video is about functions and linear equations. So, first thing we're going to talk about is determining whether something is a function or not. So, first, the vertical line test is where you take your pencil across the paper and you drag it. And as long as it only hits one point at a time, that is a function. Alright, so here for example, it's 1 point, 1 point, 1 point, 1 point, all the way through, even at the peaks. So this is a function. So this is a function. Second one, same thing. Vertical line test, take your pencil vertically, drag it across the line, only hits 1 point at a time, so this is indeed a function. This one? Nope. Hits 2 points, so it is not a function. And same case here. Hits 2 points when you drag your pencil across. So this is not a function either. Okay, next I'll be talking about the domain and range of graphs. So just looking at these, we need to be able to know our definitions of domain and range. Domain is just all the x's where the function exists. Range is just all the y's where it exists. So, we look at our first one. Set notation is with inequalities. Interval notation is a little bit different. We'll talk about that in a second. So our domain, we're talking about our x values. Set notation is written weird, but all it is just the notation. So we're doing domain, so we're talking about x, and that's just how the notation looks. And we need an inequality for it. So x is from 1, and it's everything bigger than that. So x is everything greater than, and it includes it, so it's equal to, greater than or equal to 1. That would be our inequality. For interval notation, it's a little bit different. We're starting at 1, and since it's closed, we use a bracket, and it goes to forever and ever that way, which we call infinity. And infinity we never close with a bracket, we just use a parenthesis. For range, range is y values. So here, our range starts at, what y value is this? 0, right? So, since it's range, we're dealing with y values. And its y is everything, well, it keeps going up and up. It might go up slow, but it keeps going forever. Y is everything greater than or equal to 0. So for interval notation, it starts at 0, and it goes to up and up to infinity. For number 2, it's kind of bounded. They both stop. So it doesn't keep going. If there's no arrow, it stops. So for our domain, that's x values. Look at where it starts on the x-axis. So here, the first x value is -2. And it goes to 3. So x is everything between -2 and 3. So that's how we're going to write it. -2 is less than or equal to all of our other values because it's the smallest. X is less than or equal to +3. Similar for interval notation. Since they're both filled in circles, we use brackets. From -2 to 3, bracket. If it's an open circle, we would use a parenthesis. Set notation for range, we're using y values. Y is going from -3 here to +4. So we're going to write it almost the same just with y's. -3 less than or equal to y less than or equal to 4. And same thing, they're both closed circles, so we use brackets. Lowest value to the highest value. Last one. Domain. For set notation, written same way, x exists Well, this keeps going this way, and it keeps going this way, so it's all of them. How do we say that? It's all real numbers, right? Interval notation, you could say negative infinity, because that's our furthest value back this way, to positive infinity. So it's going to be negative infinity to positive infinity, just like that. Our range is a little bit different, because it's coming from negative infinity, and it's stopping at 3, because that's our highest value. So, for set notation, y is everything less than 3, right? So it's y is less than or equal to 3, because it still is including the 3. This is a filled-in circle up top. And we would say it starts at the lowest value is negative infinity, and it goes to the highest value is 3. Okay, next I'll be talking about the domain of functions. So we know our domain restrictions, there are 2 of them. A function cannot have a negative under a square root, and it cannot divide by 0. Alright, so first we have a fraction here. So there's no square roots, so we're only using the one rule. We cannot divide by 0. So we have to figure out what value will make this 0 down here. So a good way of doing that is just set it equal to 0 and solve the equation. Or you could see, what number plus 1 makes this 0? Negative 1. So x is not allowed to be negative 1, because it will make the bottom 0. So our domain is going to be, for set notation, x is everything, but it's not negative 1. Because if you plug in negative 1, you get 0. And for interval notation, that's a little bit different, because all we're doing is we're skipping over that one number. We're skipping over negative 1, and it's everything else. So for interval notation, it's going to be negative infinity to negative 1, union, because there's a break, negative 1 to infinity. Next one is a square root, and we know we're not allowed to have a negative under a square root. So first we'll look at a number line. What number will make it 0 on the inside in here? What number plus 4 is 0? We know that's negative 4. We are allowed to have the square root of 0. That's 0. So this, we're allowed to plug in. So it's a closed circle. And if we plug in, say, 0, 0 plus 4, that's positive. That's okay. But if we plug in anything before negative 4, we get a negative under a square root. It's not okay. So it's everything this way. So for set notation, it's x, since we're talking about domain, is everything x is greater than or equal to negative 4. For interval notation, we can pretty much follow the graph. It starts at negative 4 with the bracket because it's closed, and it goes to infinity, right? And the last one. Absolute values. There are no restrictions with absolute values, only square roots and dividing. So, since there are no restrictions, we can plug in whatever number we want, so therefore the domain is going to be all real numbers for set notation. X is all real numbers. And for interval notation, negative infinity to infinity, because we can plug in whatever we want. Okay, next thing, evaluating functions. So when you're evaluating, you're usually just plugging in numbers. We're given 2 functions. F of x is 3x minus 4, and g of x is 2x minus 1. And it first wants us to find f of 3. So all we have to do is plug in 3 into x for this first one. So we're going to get 3 minus 4 times 3, which is 3 minus 12. So f of 3 is negative 9. If it says f of x equals 11, that means it wants you to plug in 11 into the f of x. Alright, so this time we're going to replace the f of x. So we're going to have 11 equals 3 minus 4x. And we're going to solve for 11. So, add 3, or minus 3, because we're adding 3. And that's going to give us 11 minus 3 of 8 equals negative 4x. Last step, divide by negative 4. So, f of x, or y, is 11 when x equals negative 2. When it says find f minus g, that means it wants you to subtract the function first, then plug in the number. So first, f minus g of x is 3x minus 4 minus 2x minus 1. 3x minus 4, or 3 minus 4x, minus 2x minus 1. Now you can't plug the number in here, but we're going to simplify this a little bit. This is the same as 3 minus 4x. Distribute the negative, negative 2x plus 1, and then add like terms. So 3 plus 1 is 4, and then negative 4x minus 2x is negative 6x. So really, f minus g of x is this. And if we're plugging in 3 into x, we're going to have 4 minus 6 times 3. So f minus g of 3 is 4 minus 6 times 3 via this equation. 4 minus 18 is negative 14. So that's f minus g of 3. We're going to do the same thing for the next one. We have f over g of 2. So first we want f over g of x, which is just 3 minus 4x over 2x minus 1. Can't simplify that, so we just plug in the number they want. They want us to plug in 2. So f over g of 2 is 3 minus 4 times 2 over 2 times 2 minus 1. It's 3 minus 8, because we're using order of operations, multiplication before we add, over 4 minus 1, which is negative 5 over 3. And you can't simplify that anymore. So it's just negative 5 over 3. Alright, next we'll be finding the slope of lines. So we know the definition of slope is just rise over run, or the change in y over change in x. We know our formula. M equals rise over run, which is y2 minus y1 over x2 minus x1. Okay, so when they give you a graph, you don't really have to use the formula. You can just count. Rise over run. So our rise from this point to this point, the ones they give us, 1, 2, 3. So we have a slope of 3 over 1, 2, 3, 4, 5, 6. But you can't leave it like that because you have to reduce it. So the actual slope is divide by 3, 1 over 2. This one, same case, rise over run, but this time we're rising down. And we always go from left to right. So we're rising down 1, so that's going to be a negative slope when it's going down from left to right. And then we run 1, 2, 3. So it's negative 1/3 this time. And you can't reduce that, so you're done. When they give you points, you have to use the formula. So we know we can call this x1, y1, x2, y2. So our slope is y2 minus y1, that's 1 minus 6, over 3 minus 4, which is 1 minus 6 is negative 5 over negative 1. 5 divided by 1 is 5, and 2 negatives make it positive. So the slope here is 5. And the last one, same case. M equals y2 minus y1, 4 minus 4, over negative 3 minus 2. Now you can do the math here, or you'll just see that it's going to be 0 over some number. 0 divided by anything is 0. So that's the slope of that one. Now remember, if the 0 appears on the bottom, say you have some number over 0, you can't divide by 0. That's undefined. Alright, now we're going to be graphing using slope-intercept form. And we know slope-intercept form is just y equals mx plus b. So the number in front of x is the slope, and the last number is the b, which is y-intercept. So we know here, right away, slope is 3, negative 3. Or you could say negative 3 over 1, because that's the same thing. And the y-intercept is a point. It's not just a number. We know it hits the y-axis, but it's still a point at 0, 1. So it's always 0, b. And then you can graph it. We have a point at 1, and we're going down 3 over 1. So we have a point at 1, and we go down 1, 2, 3 over 1. And that's going to be our line. You only have to graph 2 points to graph a line. Next one, we don't have y equals mx plus b form, so we're going to have to find it. Now to do that, all you have to do is solve for y. Since we have to solve for y, we have to move the 2x, because you're trying to get y by itself. So we minus 2x to get rid of it. Those will cancel, but these are not like terms. So our equation is going to be y equals negative 2x plus 4. Always put the x term first when you're graphing. So our slope here is negative 2, and our y-intercept is 0, 4. And then you can graph it. So we start at 4. 1, 2, 3, 4. And from there we go down 2 over 1, right? So down 2 over 1. And that's the line. Next one, same case. We have to solve for y, because y is not yet by itself. So divide by 4 for all your terms. So our equation becomes y equals 3 over 4x. You can kind of separate the numbers and put them out front. X minus 8 divided by 4 is 2. So now you have your slope and your y-intercept. You don't really have to state them. The slope is 3/4. Rise 3, run 4. Start at negative 2. Start at negative 2 and you go up 3 over 4. So up 1, 2, 3 over 1, 2, 3, 4. Here's our point. And your line. Alright, next we're going to use the x and y intercepts. And intercepts are just where they hit the x and y axis to graph them. So first we have 3x plus 5y equals negative 15. So, to find the x-intercept, all we have to do is plug in 0 for y. So we plug in 0 for y. We have 3x plus 5 times 0 equals negative 15. We know that's going to go away. 5 times 0 is 0. So we divide by 3, and x equals negative 15 divided by 3, negative divided by positive is negative 5. So that's our x-intercept. That's where it hits the x-axis. And then we're going to do the same thing for the y-intercept. We plug in x equals 0. So we have 3 times 0 plus 5y equals negative 15. We're using the same equation, just plugging in 0 for x this time. So 3 times 0 is 0, and we divide by 5. So our y-intercept is negative 3. And now we just plot those 2 points. X-intercept is negative 5, so it hits the x-axis at negative 5. and hits the y-axis at -3. So your line looks like that. So we're going to do the same thing for this. 3x minus 2y equals -12. So to find our x-intercept, plug in y equals 0. So our y term is going to disappear here. So we're just going to have 3x equals -12. Because that's going away. Y is 0. 2 times 0 is 0. So we divide by 3. That gives us our x-intercept. Our x-intercept. -12 divided by 3 is -4. So that's our x-intercept. And the y-intercept? Same case, but x equals 0. So that makes the equation, x term disappears, we have -2y. Don't forget your negative. Equals -12. To solve, since we're multiplying, do the opposite and divide by -2. And that'll give us our y-intercept. Because those are going to cancel. And y equals -12 divided by -2 is a positive 6. So we graph it. X equals -4 on the x-axis. And y is 6. Up 6. Line. So next we'll be graphing horizontal and vertical lines. Whenever it's x equals, it is a vertical line. And whenever it's y equals, it's horizontal. So these are pretty easy. First one, x equals 3, so go over 2. X equals 3. Plot a point, and it's a vertical line. Done. So for y equals -3, you're going to do the same thing, but with the y-axis. Down 3, plot a point, horizontal line. Another thing you need to know about these is their slope. For the slope of a vertical line, you have a rise, but you don't have a run. So the slope of a vertical line, you'd be dividing by 0, which is undefined. For the horizontal line, you have run, but you don't have a rise. So your slope is going to be 0 over some number, which is 0. Alright, so f of x we know is the same as y, so for number 3 we have y equals 4. So go to y equals 4 on the y-axis, and a horizontal line is the graph. And the last one, it doesn't exactly give us a proper equation. We have to solve for x first. So add 1. Both sides, x equals 1. Plot a point at 1 on the x-axis, and draw a vertical line. Alright, next I'll be talking about point-slope form. And point-slope form, we know, is just y minus y1 equals m times x minus x1. So here they just give us a point and a slope. So when they give you a point and a slope, automatically you can put it into an equation, point-slope form. So just plug them in. We have y minus -1 equals, our slope is -3/5, x minus -2. When you minus negative, really you're just adding. So make them plus, -3/5 stays the same, x plus 2. And since it just wants point-slope form and not slope-intercept, we're done. If it wants slope-intercept, you have to solve for y and distribute. So for the next one, they give us 2 points, but no slope. So that's the first thing we have to find is slope. But we know the slope formula is just y2 minus y1 over x2 minus x1. So subtract the y's. 6 minus 2 over 5 minus 1, which is 4 divided by 4. So our slope here is 1. And we can pick either point, whichever one looks easier to deal with. 1, 2 definitely looks easier. So we'll use the point 1, 2 to find point-slope form. So from there, we just plug it in. Y minus y1 is going to be y minus 2 equals the slope is 1, x minus 1. And since that's just a 1, you don't even need it. So you could get rid of that, same as y minus 2. And we'll just go ahead and convert it into y equals mx plus b form, since it's really easy to do it. 1 times anything is just itself. So if it wanted slope-intercept form, all you have to do is distribute and then move this number over. So we get y equals mx is just going to be x, and then 2 minus 1 is 1. So this would be slope-intercept form because that would be y equals mx plus b. Alright, and the last thing I'm going to talk about is parallel and perpendicular lines. Now they love to ask these on tests like the PERT test. So parallel lines we know have the same slope. Whereas perpendicular lines have opposite reciprocal slopes. So the question, find a line parallel to y equals 4x minus 3 that passes through this point. So we know the slope of this line is 4. So therefore the slope of our new line is also going to be 4. So we have a slope and we have an x1, y1. Just plug it into point slope form. So that would be y minus y1 equals m, x minus x1. So plug in our numbers, y minus negative 3. So if we're minusing the negative, it's going to be positive 3. Equals 4, x minus 6. I'm going to stop there, but you could keep going on to slope-intercept form if you want to. Or if you have to. Alright, find a line perpendicular to this line. So the slope here is 4, or 4 over 1. So therefore our perpendicular slope, written that way, is going to be opposite. So if this is positive, it's going to be negative. And the reciprocal of 4, or 4 over 1, is 1 over 4. So this is the slope we're using for our new line, with the same point as the last one, x1, y1. So y minus y1 equals m, x minus x1 becomes y minus the negative 3 means plus 3. It's pretty much going to be the same thing with the different slope, which is negative 1/4, x minus 6. And that'll be it for today.